Continuing a look at our trig functions for acute angles. There is some general rules for how function values change as an angle changes. So if we're looking at the measure of an acute angle A, as it increases from 0 to 90 degrees, so we're really only looking at this first quadrant here. The value of sine of A is going to change, and the value of cosine A is going to change. Now, to illustrate this, I'm going to draw some triangles. We do want to remember that sine is associated with the y, and cosine is associated with the x. So let's start with a triangle of a lower angle measure. So there's our first triangle. Here's its angle. Now, if I make an angle that's just slightly bigger, but keeping that same length of the radius or the hypotenuse, what can we observe has happened between the x's and the y's? So we started with an x value here, and now we've got an x value here. We started with a y value about here and ended up with a y value about here. Now, if I do one more, let me show that angle. So we can see the green angle is smaller than the blue angle. And then lastly, if we make an even bigger angle, so that pink angle, we can see that our x values are actually getting smaller and our y values are getting bigger, looking at these ordered pairs. So the sine, which corresponds to the y, is going to increase. And the value of cosine is going to decrease. Now, this is only true when we're looking in this first quadrant. We will observe some other relationships as we move into second, third, and fourth quadrants. But we're just making these generalizations within that first quadrant. Determine whether each statement is true or false. Cosine of 21 degrees is less than cosine of 18 degrees. Well, we just saw that as our angle increases, the value of cosine decreases. So cosine of 21 is going to be smaller than cosine of 18. Is this inequality true? A smaller value is less than a larger value. This is true. However, if we look at sine, we know that as our angle increases, the value of sine increases. So this is the larger of the two, and this is the smaller of the two. And now we're looking at a statement that says a larger value is less than a smaller value, which is false. Next, we're going to review some special right triangles. There are two special right triangles we're going to look at. Maybe you remember these from a geometry class. If not, you can just note them now. We have a 45, 45, 90-degree right triangle, and this is an isosceles right triangle. If both of our angles outside of the right angle are equal, then it does make, or if we have two equal angles, that makes this an isosceles triangle. We did classify triangles by their side lengths in a previous video if you wanted to go back and review that. But if we know that the length, or we assign the length of one leg to be a value of 1, the other leg is also going to be 1, and it would follow using the Pythagorean theorem that the hypotenuse of this right triangle is the square root of 2. The next is a 30, 60, 90-degree triangle. And here's our scalene triangle. This one's going to be 30 degrees. This is going to be 60 degrees. If we assign the length of the side opposite 30 degrees to be 1, then it holds true that the hypotenuse is 2 times that, so 2, and the other leg, the longer leg, is equal to the square root of 3 times 1, or just the square root of 3. Now we can use these special right triangles to start building out trig functions for these special angles, the 45 or the 30 degrees, 45, and 60 degrees. So our trig function values for special angles, sine of 30 degrees is 1/2. Again, if we're looking at sine of 30 degrees, all I'm doing is using these triangles that I've drawn here. Here's our angle 30, sine is opposite over hypotenuse. So we're putting together these special right triangles and that acronym SOHCAHTOA that we learned previously. Cosine of 30 is the square root of 3 over 2. Tangent is the square root of 3 over 3. Cosecant is 2. Secant is 2 square root of 3 over 3. And cotangent is the square root of 3. Now, some of these are very obvious from those triangles. Others, we would need to do some manipulation. And in future examples, we won't try to memorize all of these values in particular. The tangent, cosecant, secant, cotangent, will derive them or work with the sine and cosine values to find them. But this will be a nice handy table to have for a quick reference while you're working through problems. Sine of 45 degrees is square root of 2 over 2. Cosine of 45 degrees is square root of 2 over 2. Tangent is 1. Cosecant is the square root of 2. Secant of 45 degrees is the square root of 2. And cotangent is 1. Sine of 60 degrees is the square root of 3 over 2. Cosine of 60 degrees is 1/2. Again, just a quick, wanted to point out those cofunctions. Remember, 30 and 60 are complementary angles. So sine of 30 is equal to cosine of 60. Likewise, cosine of 30 degrees is the same as sine of 60 degrees. So just another illustration of those cofunctions. Continuing, tangent of 60 degrees is the square root of 3. Cosecant is 2 square root of 3 over 3. Secant is 2. And cotangent is square root of 3 over 3. Now these values, again, specifically the sine and cosine values, we're going to come back and practice those a lot, especially when we introduce the unit circle here soon.